Hello everyone. In this video I'm going to show you how to use reciprocal, Pythagorean, or addition and subtraction identities to calculate trig functions for unusual angles. So this is the list of trig identities that we'll have available to us. I have reciprocal ones, Pythagorean identities, and the addition and subtraction formulas. There are some other identities that could be helpful for these particular problems, but we can make do with these ones. So here are some questions. Let's start off with number 1. For a certain angle phi, it is known that sine of phi equals 5/13, and we know phi is in quadrant 2. Use a trig identity to find the exact value of cosine of phi. Okay, so I'm going to write down what I know, which is sine of phi equals 5/13, and I'm going to write down what I want, which is cosine of phi. Oh, and we also know it's in Q2. All right, so now I'm looking for an identity that relates cosine and sine of the same angle, and there's not much else in the identity than that. So I'm going to go through my list here and see where do I have sine and cosine in one identity. So here I have tangent equals sine over cosine. So I do have the same angle in sine and cosine, but I also have the tangent, and I was not given the tangent in this problem, so this would not help me. So I'll keep going. Here I see another identity that has sine and cosine of the same angle in it. And there is another thing in here, which is the 1 and the squares, but there's nothing unknown. I know the value of 1. There's not any other trig functions. So I am going to use this one. So let me write it down first. Sine squared theta plus cosine squared theta equals 1. So it's kind of like you have this box of tools, like a toolbox, and you have, like a bolt that you want to screw in, and you're looking for the wrench that's the right size to fit it. So this is your wrench here that fits the bolt that you have, if that makes sense. Okay, so this is an identity, which means that we're allowed to plug in anything we want for theta, as long as we plug it in for all of the thetas. So we're actually going to use this on phi. That's the angle that we're going to apply this to. So I'm going to write phi instead of theta. Okay, and now I'm going to try to plug in the fact that I know sine of phi is 5/13. So to do this correctly, I need to interpret this notation correctly. This square between the sine and the angle is actually a shorthand way of writing sine of phi in parentheses squared. And the same for cosine here. This is a shorthand for cosine of phi in parentheses squared. It's just that, I don't know, some guy back in the 1600s or something probably got lazy and didn't want to write those parentheses. Well, ink and candles were expensive back then, so we can't really blame him. All right, so we're going to plug in 5/13 here for sine of phi. So we're replacing that whole sine of phi thing with 5/13, and that's going to be squared. Okay, and then we still don't know cosine of phi. That's actually what we're going to solve for. So now what I'm going to do is I'm going to start trying to solve for cosine of phi, meaning I'm going to isolate it. So I'll start by moving away the things that are the farthest from it. So I'll subtract 5/13 squared to the other side of the equation. And I'm going to give myself lots of room here because I have exponents and fractions and things. You always can give yourself more space. Let me write this fraction upright like this. Okay, I think I'd like to go ahead and calculate this side now because I'm going to need to square root it next. So let me see if I can simplify it any. So this is going to be 5 times 5 over 13 times 13. Okay, so this is 1 minus 25 over 169. I just have all the squares up to 13 memorized. And now 1, I'm going to try to get a common denominator between these two terms. So 1 is the same as 169 over 169. Being able to simplify these kind of fractions pretty quickly will be a big help in calculus. Okay, so 169 minus 25, you can use a calculator, or just do 9 minus 5 and 6 minus 2, since they're bigger. So this is 144. And these are both over 169. And this is great because going back to, let me include the left-hand side again. Okay, this is cosine squared equals 144 over 169, and I want to square root both sides, so these are both perfect squares. That's going to make it easy. Okay, so now I'm going to square root both sides, and I want you guys to not forget that when you're solving an equation and you use a square root like this, you must put plus minus on one side, because cosine of phi could have been either positive or negative. Either one of those would have satisfied and given the same value after being squared up here. Either one would have given us 144 over 169, because a negative value squared becomes positive. Okay, so these are my two possibilities for cosine of phi. But remember, we were given this extra clue at the beginning that the angle is in quadrant 2. So quadrant 2 is here, and x values are negative in quadrant 2. So so that means that cosine of phi would have actually been negative. So this will be the correct value for cosine of phi. All right, let's do another problem. So for number 2, we're going to use the information that we just found to find cosine of 2 phi. There is a double angle identity that will tell you how to find cosine of 2 times any angle, but we're going to try doing this with just the addition identity, because 2 phi is the same as phi plus phi. Okay, so for number 2 here, I want to calculate cosine of phi plus phi, and I'm going to roll up to my cosine of an angle plus an angle identity, which is this one. So basically what I'm going to do is I'm going to plug in phi for both s and t. I'm allowed to plug in anything I want for those angles because it's an identity, so I can do the same angle for both of them if I want to. So this is going to be cosine of phi, I'm just copying, minus sine of phi, sine of phi. Let me double check, does this actually match? Cosine of phi minus sine. You have to be careful because the minor little changes make it a different formula. Okay, so now I think I actually know what all of these are, right? Because I have cosine right here, cosine of phi, and then I was given sine of phi in the last problem. Okay, so I'm just going to plug those in. So cosine of phi was negative 12 over 13, and I'm doing that times itself, so it's squared. And then I'm subtracting 5 over 13, and again, this is times itself, so I'm squaring it. And yeah, now I can just simplify this. So negative times negative becomes positive, and in the top I'm going to have 12 times 12, 144 over 169, and minus, this is going to be 25 over 169. Okay, and you can do 144 minus 25 on a calculator, or you can do it like me, first subtract 20, then subtract 5. 144 minus 20 is 124, 124 minus 5 is 119. And that's it. By the way, my cat is here to say hello, so hello!